Hey, so my name is Josh Richard. I'm here to show you the Spindle line in our Experience Center. The Spindle line is very special. 2.5 years ago, DMG Mori and Tulip worked together to digitize their Spindle line assembly. We did this in Pfronten, Germany, which is about an hour and a half outside of Munich. It's here where they conduct the assembly of the DMU machines, and this spindle is the Speedmaster that's in each one of them. There are a couple of things that we're doing here. We're doing some part picking and some assembly, as well as some inline quality checks. Basically, in real life, this is 4 times larger, and so this fixture will come down the track. An operator will have a barcode scanner here to scan the SKU. We'll pull directly from their ERP to get the bill of materials for this assembly process for the one at this bay. We're guided with some pick-to-light on some parts that we want to pull to work on our spindle. Once we've done that, we're going to do some manual checks on the encoder wheel. So we can check off that we did that. If we try to continue, we'll be asked to either report a problem or continue with our operation. So we're like halting the operator's progress until we complete all of our tasks. We're going to collect a concentricity measurement here. In this case, it's 20 microns of deviation. So we do that with our Edge IO and this concentricity gauge right here from Mitutoyo. Once we've done that, we'll do some more quality checks, and then we'll push it down to the next bay. Okay, once we get down to this bay, you'll see that the application automatically started. That is thanks to some computer vision. Right now, in production, they use RFID tiles that are mounted to the fixtures. That tracks both their position and also the uniqueness of a fixture. So they can do any number of things. They can do material flow and track their progress of each spindle as it goes through the assembly. And then they can also use that to do time estimation. Once it gets down here, we're prompted to pick some more things. If I pick from the wrong bin, it'll tell me with some very bright red lights. If I were to pull my items here, I'll have some automatic feedback. These lights will turn white, and then I'll get some check marks here as well. This is done also with computer vision. We have set regions of interest along each bin, and so it can identify when a hand will enter a region or not. And it will do so with a depth perception. So once we've done that, we'll continue our progress, and we'll do another quality check. We'll have some manual checks of the spindle, and then we'll do some more data capture with our Mitutoyo digital caliper here. In reality, they measure the depth of this encoder wheel along the entire spindle. For our purposes, let's measure 5.65 millimeters. That automatically gets sent to Tulip, and then we can check everything off and push it down to the next bay. So really happy, really proud to show you what we did 2 years ago and the progress that we've made with DMG Mori. There's a lot of iteration that happens, a lot of continuous improvement over 2 years. And so this is a great example of what a very mature implementation of Tulip looks like.